the last feature, the last important TypeScript feature I definitely want to cover here in this introduction is the generic types feature. Now, you might recall that I mentioned this feature earlier when we created this array. If I have a roles array, that should be an array full of roles, I could create it like this. I'm using my custom role type for that, and then this built-in array type, which is such a generic type, as I mentioned before. And as you can see, if you remove this related type, then we learn that this generic type requires one type argument. And such a type argument is passed with help of those angle brackets. Now roles would only accept my role strings here and not any other strings. Now, I did mention that we could have also written it like this, and it would have basically worked in the same way. Nonetheless, this here is an example for a generic type, a built-in generic type. But you can also build your own generic types, and you might now wonder why exactly you would do that, what the benefit of that is, and what exactly generic types are in the end. Well, as mentioned, generic types are types that work together with another type. An array works together with the type that's inside of the array, for example. Now, we don't just have built-in generic types like array here, so built-in types that need another type to be specified in a precise way, so to say, but we can also build our own generic types. For example, we could build a data storage type here, which should be an object type in the end, where I want to have a storage property which should be an array, but an array full of data which I don't know in advance. So I don't know yet what the shape or the type of data will be that should be stored in there. It could be a bunch of strings, it could be a bunch of objects. Therefore, we need a type placeholder here, or put in other words, this data storage type, which I'm creating, will be connected to another type. It will need extra type information to be truly specific. And therefore, I want to create a generic type here, where I expect extra type information at the point of time where this data storage type is going to get used somewhere in my code. And for that, we can add angle brackets here after the name of this custom type, and then add any placeholder name of our choice between those angle brackets. Typically, you use T for type, but any name and any character of your choice is fine. You could also have multiple placeholders here if you would building a more complex generic type that needs multiple related types, but here I'll just go with one for now. And now I can set the type of storage to an array of T's. So I know it will be an array, which itself, ironically, is a generic type, but it will be an array full of values which types I don't know yet. And we could then, for example, also add a method to that object by adding a property and then using a function type as a value, because that is what a method in the end is. It is a property that stores a function. And then here in this add method, we will probably expect to get some data as an argument, as a parameter. And now the type of that data, of course, will also be that generic type placeholder, because again, we don't know it yet. Data storage can be used with all kinds of data later. And then here, this function, this method will probably not return anything. It could return the updated storage. So we could return this storage array here, for example, if we wanted to, but here I'll not return anything. And we can, of course, also add a delete method if we wanted to, but here I'll keep it simple and just add data. So now with that, we have a custom generic type here. And now we can use this type to create multiple storages for different data because it's a generic type. So we could have our string or our text storage here, which should be of type data storage, but now here we want to store a bunch of strings in that data storage. So I pass string as a value for this placeholder. That's how that works. This value here between the angle brackets here, when I'm defining my concrete type, that string value is used as a value for this t placeholder in my generic type definition. And with that, we now create a data storage object here in the end, which will have our storage array, which initially might be empty, but which must be full of strings, because we define that here, that the storage must be an array full of values of that type, and that type here now is a string. And we add our add method here, and that add method now also must accept data, which is automatically inferred to be of type string, because again, that's what I defined here in this general generic type definition. That data, this argument here, this parameter, is of that generic type, so to say. So it will be of type string down there. That's how we define and then use a generic type. And then here we could add any logic we want. For example, that we simply reach out to this storage and push our data onto it. Now, of course, we could now also create a user storage, for example, where we also use that data storage type, but where we now expect to get user data in it. So here that storage array is now an array full of user objects in this case. So I'm only allowed to add objects that have this shape with these properties. And the add function therefore expects to get a user of type user with which we can then work. And that's the idea behind generic types. You define them once, but in a flexible way, and you can then use them in conjunction with specific other types in different places to, for example, store different data or do whatever you need to do with different data. It's worth noting that in TypeScript, you cannot just define generic types like this with help of the type keyword. Instead, you can, for example, also define a so-called generic function by using the function keyword, as you always do if you want to create a function. And then here we could, for example, name that merge and add the angle brackets after the function name to then maybe use two placeholders, again with any names of your choice, but T and then U are common choices, so that we can accept two parameters which use these different placeholder types. And we then maybe return a new object which is the combination of A and B with help of the spread operator that's built into JavaScript. And now we could use this function by calling merge, and we can then add the angle brackets here and define the shapes of the two types that we want to use for the parameters. So for example here, both types should be objects, and the first object should have a name property, which is of type string, and the second object should have an age property, which is of type number. So with that, I'm setting up my connected types for this generic function, and I'm therefore telling TypeScript which kind of data is expected for these two parameters. So when I now pass these parameter values, I have to pass two objects as values, and the first object must have that shape, because I'm setting up this object type definition as a value for this placeholder. And I'm then saying that that should be used here as a value for the first parameter. Therefore, that's now the shape I have to use here for that first argument I'm passing to merge. I have to add a name property here. And for the second argument, I have to use this shape of the second generic value. So the value I'm using for the U placeholder here. In this case, I want to have an age here. Well, and with that, I'm getting such a user object, which is actually a name I'm already using here. So I'm naming it new user to avoid name clashes. And now new user has an age and a name property, and I'm getting autocompletion here because TypeScript, and therefore also my IDE, understands that I'm passing these two objects as values to merge, and it knows the shape of these objects because I defined this as a generic function, which works with different related but clearly specified types. And that's what we're doing here. And here we could actually even remove these angle brackets and these type definitions, because when we have such a generic function like this, and we're then passing values for these different parameters, which are connected to different type placeholders, if we do that, TypeScript is able to infer that the value passed must be of the type of this first type placeholder, since I'm using the T type for the first parameter. And the value used for the second parameter, or the type of that value, must be the type of that second placeholder in this example, since I'm using that U type placeholder for the second parameter. So TypeScript is able to infer all these things, and I still get this autocompletion and this type safety. And whilst this generics feature therefore might still be a bit confusing, it is a crucial feature which you will also encounter again later in the course, and which I therefore wanted to mention here already.